Welcome to today's lecture on statistics and probability. Today we're going to be looking at independent events. When we have an independent event, we are doing probability with replacement. And what this means is that each trial or each experiment is done independent of the other ones. So what this means is we'll do our first experiment, then we'll hit the reset button and start over with all of the same criteria or data that we did in the prior trials. This makes each trial independent, or the results of each trial independent from each of the other trials. So they don't depend, or what happens in one trial does not affect the results of another trial. Let's look at a problem to help us understand independent events. In this problem, it says we have a bag that has 1 green, 2 red, and 3 blue marbles. What is the probability of drawing 2 blue marbles? What is the probability of drawing a green and then a red marble? And what is the probability of drawing one of each color? So for this problem, we're going to have 6 possible outcomes: 1 green, 2 red, and 3 blues. Now, because this is an independent event, there's going to be experiments with replacement. Then after we do our first drawing, we're going to draw a marble, then we're going to put that marble back, and then when we do our second experiment, we're going to once again draw from the bag with 6 marbles. So we're going to have 6 outcomes for each of my experiments, or each trial, each time I draw a marble out of the bag. And then, like we saw in the prior tutorial, when I'm solving for the probability of an event, it's going to be the number of possible outcomes divided by the total number of possible outcomes. So my probability for drawing a green out of the bag is going to be 1/6. Probability of drawing a red is going to be 2 out of 6, which simplifies to 1/3. Probability of drawing a blue is 3/6, which also can simplify to 1/2. For both of my trials, when I draw my first marble and when I draw my second marble, those values, those probabilities, and the total possible outcomes are going to be exactly the same. So let's look at the first question. What is the probability of drawing 2 blue marbles? So once again, we're starting with a possible outcome of 6 marbles each time I draw a marble. And the probability that I'm going to draw blue out of those 6 marbles is going to be 3 possible blues out of the 6 marbles, which means I have a 1 out of 2, or a 50% probability that I'm going to draw a blue marble each time I draw a marble from the bag. So now to calculate what is the probability of drawing 2 blue marbles, I'm going to take the probability of drawing a marble from the first draw and multiply that by multiplying the probability of drawing a blue from the second draw. So that's going to give me 3, 6 times 3, 6, which can simplify to 1/2 times 1/2, which equals 1/4, which converts to a decimal of 0.25, which is 25%. So I have a 25% probability that if I draw 2 marbles out of the bag, one, draw a marble, then replace it, and then draw a marble again, that I'm going to have a 25% chance that 2 marbles are going to end up being blue. Now let's look at the next question. What is the probability of drawing a green and then a red marble? We're going to do the same thing. Both times we're going to start with 6 marbles in our bag. I have 6 marbles. I'm going to draw a marble out. The probability of getting a green is 1 out of 6. Then I'm going to put that green marble back in my bag. I'm going to draw a marble out again from the bag, and this time I want a red. The probability that I'll draw red is going to be 2 out of 6, which simplifies to 1/3. So once again, to get the probability of first drawing a green and then drawing a red, that's going to be 1/6 times 2/6, which can simplify to 1/6 times 1/3, which equals 1/18, which is a decimal of 0.0556, which gives me a 5.56% probability that I'm going to draw a green and then a red. Now, one thing you'll notice is that when I have independent events, I could reverse the order and draw if I had chosen I wanted to get the probability of drawing a red and then a green, my answer is going to be exactly the same. I'm just going to flip the numbers. I'm going to multiply the probability of the red times the probability of the green, and it's going to give me the exact same answer because these are independent trials and we're starting out with the exact same number of marbles and the exact same probabilities each time I do my experiment. Okay, let's look at the last example. With this one, we want to know what is the probability of drawing one of each color. So this time we're doing 3 experiments or 3 trials, and we're going to draw a marble, then put it back, then draw a marble again, then put it back, and then draw a marble a 3rd time. So each time we're going to have the sample space of 6 possible outcomes, 1 green, 2 red, and 3 blue. For our first trial, we want to get the probability of drawing a green. So we're going to draw a green out of the bag. Green has the probability of 1 out of 6. Then we're going to put the green marble back, draw a red. The probability of drawing a red is 2 out of 6, which can simplify to 1/3. Then we're going to put the red marble back and draw a blue out of the bag. That has a probability of 3 out of 6, which is 1 out of 2. Then to get the probability of drawing those 3 marbles out of 3 independent trials, we're simply going to multiply their probabilities times each other. So that's 1/6 times 2/6 times 3/6, which can simplify to 1/6 times 1/3 times 1/2. Doing that multiplication gives us 1/36, which becomes a decimal of 0.0278, and that gives us a percentage of 2.78. So we have a 2.78 probability that if I did 3 independent trials, I would independently draw out one of each of the colors of the marbles that are in my bag. Now once again, because this is an independent, these are independent trials, I could put these in any order and I'm still going to get the same results. So we have calculated the probability of drawing a green and then a red and then a blue. Well, I can put that in a different order. I could do that in reverse order. Draw a blue, a red, and then a green, and I'm going to end up with the exact same results. Or I could mix it up and do a red and then a green and then a blue, or a blue and then a green and then a red. There's lots of different combinations of the orders, but the numbers are still going to be the exact same. So if I have an independent event and I'm going to replace my marbles each time I do my experiment, set the reset, then each of these are independent. They aren't affected by what happens in the prior trial. So to summarize, when you have an independent event, it means you're going to do your experiment, then you're going to reset all of your data so that you're starting with all of the same criteria, the same number of outcomes as you did on your first one, and the results of one trial do not affect the results of the other. I hope you have found this helpful. See the links below for additional supports and resources, and be sure to like and subscribe to get the latest videos from Caz Academy. I'll see you at the next video for more statistics and probability.